want to find the solutions to y greater than 4x minus 3. Step 1, graph the boundary line. Boundary line. Well, just graph this thing as if it was an equal. That's what I mean by a boundary line. So what's my slope? 4. What's my y-intercept? -3. So what do? I take -3, my y-intercept, and I graph it. Then I look at my slope of 4. We could put it over 1. That's an up 4, right 1. 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1. And normally we just go right ahead and connect the line. I'm going to pause for a moment because there's rules about the boundary lines. You remember what they were? We mentioned it briefly. Do you remember?
You would put a dash line.
Exactly. Because there's no equal here, I'm using a dashed line. It's like the open circle when we were graphing them on the number line. It says, by putting a dashed line here, that the points on this line, they are not solutions to this inequality. The points on that line are not solutions because the solutions here would be equal. So if this had been an equal, I would have made a solid line. One thing I want you to think about doing is when you make a dashed line, just make a note here that it's dashed, because I have found that sometimes when you look at it, it's hard to tell if they're dashed. So maybe you are dashing it, but it is sometimes hard to tell. So maybe make a little note, this is dashed. I know it because the boundary line itself is not part of the solution. You're fantastic. Now the solutions, y greater than 4x minus 3, I'm going to tell you where they are. This is the boundary line. The solutions are either going to be up here, above the line, or they're going to be down here, below the line. That's where the solutions to this inequality are. Up here, this half plane, or down here, this half plane. How do I figure out where they are? And there's a couple of different ways to find it. Do you have an idea how I can find where the shading goes?
With the original way we did on the number line,
Yeah.
it was kind of like the x-axis.
Okay.
And with the arrows, with this one is going to the right.
So you're saying this way because there was a little trick you guys learned with the number lines, right? If it looked like this, then you pointed that way because this looks like this.
Yeah.
And if it looked like that, you point that way. This is why I don't like tricks. The reason we go this way is because I'm looking where all the lines are bigger. The reason I go that way is because I'm looking where lines are smaller. This is not an arrow because it's not really working that same way. I do want to know where the y's are bigger. And it's not necessarily to the right. Okay, hold on one moment, please. So what I want to do is I'm going to test where it could be. So let's say maybe it's on this side, which would mean every point on this half plane is a solution. So why don't I just pick a point and see if it's a solution? If it is, I know I found the right half plane. And you know what point I'm going to pick?
0, 0.
I am going to pick 0, 0. As long as the point you pick is not on the line, and that's important. You can't pick a point on the line. But if 0, 0 is free and not on the line, it's an easy point because it's easy to work with zeros. Because watch, let's see, y would be 0. 4 times 0 minus 3, so I'm getting 0 bigger than 0 minus 3. Is 0 bigger than minus 3? Let's think about it. Is 0 bigger than -3?
Obviously.
Okay. Well, you know what? It's not always so obvious. Sometimes you have to think about it. So, somebody might feel bad when you say something like that if they had to think about it for a minute. So 0 is bigger than -3, which means this is a solution. So where is this located relative to our boundary line? This side, right? So this is where my solutions are. Now when you shade the half plane, do it the way I'm doing. See how I'm drawing it with just like lines coming over?
Yeah.
Rather than making a big dark blob, which some people like to do,
How's that?
we are just going to shade that half plane. These are my solutions. Where are the points that aren't solutions? They're down here. So we have a picture of what they look like. I want to try another example. Let's look at another example, and this is also on your notes on the bottom right. greater than or equal to 8. So the process is the same. You're going to graph the boundary line. You're going to decide solid or dashed lines. Pick a test point, and then shade the half plane. Now, an important point here is that you always want to solve this for y, because this makes this much easier. So solve it for y, again, just like if it was an equation. Subtract the 2x, and I get negative y bigger than or equal to negative 2x plus 8. All right, well, I don't want negative y, I want y. What do I do? Multiply by negative 1. Oh, wait a second. This is an inequality. I have to stop. I'm multiplying. I have to stop and ask that question, which is,
I
did
multiply.
I just
Multiply
multiply by
by
a negative?
negative.
Did I?
Yes.
I did. So what happens to this?
What?
Turn it, right? Now all my signs are changing because I am multiplying by a negative. So my m is 2, and my v is negative 8. So remember, and this is, if you're going to make a mistake, it's right here. Multiplying or dividing by a negative means to turn that symbol, reverse it. Yes?
So when you find the y for 1 like when you like there's only one eight.
Yeah. I'm just multiplying each side. Pretend this was an equal. Just like you would with an equation. I just have to take that extra step because it's not. I have to figure out if I have to turn or not. So let's see, I have to graph this. Now I'm looking at my graph here. I think I need to go by 2s. Just so that it fits on there. So my y-intercept negative 8, that's going to be over here. 2, so I'm going to go up to right 1, aren't I? So up to right 1, up to right 1, up to right 1. So I keep doing that. Hopefully I'm doing this right. I see my points now. I just don't willy-nilly draw your line. Go back and look at the sign. What kind of sign is this? Greater than or equal to? So what kind of line am I going to make? A nice solid line. That means that the points on this line are solutions because equal. Right? If this was an equation, that would be all you get. All right, now I have to decide. Now that's just this. That's just step 1. Now, which half plane? Is this half plane my solution? Or is this half plane my solutions? How do I tell?
Shouldn't that be a dash line?
If it's a greater than equal, an equal says that the line itself is part of the solution. It's like filling in the hole when you are graphing an inequality. That says this is a solution. These will all work. All the points on the line will make this true, so I want to make it dark. When I make the dash, it means it's not a solution. That help? All right, let's see. I have to figure out where to shade them. So I have to find a point not on the line. Gee, what would be a good point to test with? What do you think? I agree. Let's try 0, 0 and see what happens. Let's see, what am I getting? 2 times 0 minus 0, and I have to figure out if that's bigger than or equal to 8. Well, 2 times 0, well, 0 minus 0, that is 0. All right. 0 greater than or equal to 8. No. It's not. So is this a solution?
No.
Should I shade this part then?
No.
I have to go where it's not a solution. So again, just lightly draw the lines to show that my solutions are on this part of the plane. Any questions?
No, wait.
Yes,
What's that in the
right? Because I tested this point and it failed,
Oh.
that means they're not here.
okay.
So it's either here or here. They better put it here. Take any point you like, not on the line. I choose 0, 0 because it tends to be easy. But you can pick any point here, plug it in, and see if you get a true statement. Is this true? No. That means not a solution. They must have been on this side.
Okay.
Yeah.
So solutions are on the right side.
For this situation, yes. Now, if this had been going the other way, less than, we would have shaded up here. So it's not always going to be down here. You have to think each problem where it's going to be.
Why did you decide for it to be on the right and not on the left?
Over here, I used a test point, and he said, gee, is this point a solution? Because if it was this half plane, then every point on here would work. So I tested one, and it worked. So this is the part of the plane where it's not a solution. So that means the solutions had to be on the other side. Think about it. Think about it. Yeah.
What if it's like 110 as a solution?
110? You could do that. See if it works? It shouldn't work. That would be 2 minus 10, which is negative 8. Negative 8 bigger than, no. None of these will work, but pick anything here. Well, 1, 2, let's see, 4, 0. Let's see, 8, 9, no, 1, 2, 3, who's
Where are those?
2, 4, 6, 8. How about 8, 0? 16 minus 0, 16 bigger than 8, yes. So any point you try here. I just do this one because it's easy. You can pick any point you like. Okay, great question. Y greater than or equal to negative 3. Now the rules here are the same. Graph it like with an equal. Uh-oh. Y equals negative 3. What does that look like?
Solution.
What does it look like? What does it look like?
It's a line.
It is a line.
It's tiny, every point has a line in it.
That's exactly it. On this graph, show me all the points that have a y of negative 3. If you're forgetting what that looks like, remember the trick. Well, plot a few points with a y of negative 3. Do I care what the x's are? Not really. Let's graph them. Negative 1, negative 3. 0, negative 3. So what does that look like? This is my horizontal line. Before I drive, I look up here. Greater than, equal. Is this going to be a solid or dashed line? Solid. Because equal. Every point on this line is the solution. Now this one, let's think just using our heads right now. Where are the y's bigger than negative 3? Here's negative 3. Are they down here? No, these are smaller. Where are the y's bigger? Above. So we're going to shade all the points above. Now similarly, let's look at another example. X less than negative 1. You have to know what x equal negative 1 looks like so you can draw the boundary. This is the graph. The points, all the points on the graph with an x less than negative 1. So if you forget what this looks like, pick a few points. Put in some y values, any y values, what do we get? We get negative 1, negative 1, negative 1, 0, negative 1, 1. This is the example of the vertical line. Do I make it solid or dash? Dash, less than. So the points on this line, none of them are less than negative 1. So I'm not really including them. Again, you might want to put a little note. This is a dashed line, because sometimes it's hard to tell. And now which way would I graph? Where are the x's smaller than negative 1, right or left? Which way? Left. That's where they're smaller, so that's where you would shade. Do you have a question? You're okay? Yes.
How do you tell if it's less than?
Well, look at x less than negative 1. Here's negative 1, right?
Yeah.
What are the x's over here? Are they bigger or smaller than negative 1?
Oh, yeah, they're bigger.
And where are they smaller? This is almost like a number line, right? It is a number line. You can just check that one. Yeah?
Yep.
All right, let's see. So I need to solve it for y. So I'm going to subtract 4x. And let's see, I get 2y bigger than negative 4x plus 6. Now I'm going to divide by 2. What gets divided by 2? Everything.
Everything.
Now, it's an inequality I'm dividing. I do have to stop and think about it. And this kind of relates to your question. I just divided by 2. Is that negative?
Positive.
It's a positive number. Do I need to turn the symbol?
No.
I don't.
You're not going,
Because it's a positive number, I do not have to turn the symbol.
because you're not going through a mathematical mirror.
Well, that's true. You remember that little talk, right? All right, so the y-intercept is 3. And let's put my slope here. I'm going down to right 1, down to right 1, down to right 1, down to right 1, or up to left 1. Yes. Now, am I going, I've got a greater than sign here. Do I use solid or dashed? Dashed. Why is it dashed?
Because,
Or start thinking about it. This equation said I want to know where the y's are bigger than negative 2x plus 3. Bigger is above. So I want to be above the line. Where's above the line? Well, that's over here. So I'm going to go and shade up here, because that's where above is. If this had been a less than, I would shade below the line, and that would have been down here. Now, if this is like, what do you mean above? What do you mean below? Get used to the test point method first. Get really smooth with that, and then we'll start thinking more about above and below. But think about this. If I use this test point here, 0, 0, let's put it in. 4 times 0 plus 2 times 0. I want to know if that's bigger than 6. I'm getting, is 0 bigger than 6? No, not a solution. I do have the right half plane shaded. If you're kind of more comfortable with that kind of way of looking at it for now, that's fine, no problem. But if you're ready to think a little bit more deeply about it, greater than is above. This is above, this is below. If you're not ready for it yet, don't worry. Don't sweat it. Use the test point method. You'll get it. You will. Yes?
So when you find the answer when you start to graph it, like how do you know? I still don't understand how to shading.
How to know where to shade? All right, the shading represents solutions to the inequality. And remember how we can tell if a point is a solution? You take the xy value of the point, let's say it was this point. I want to know if it's a solution. This is 0.30. So I go back to the original inequality and say, gee, is this a solution? Let me plug in the xy values. If I get a true statement, it is. So I'm getting 12 plus 2 is 14. Is 14 bigger than 6? Yes, so this is a solution. If I tested every single point here, I would get a true result. If I tested every single point here, it would be false, not a solution. I pick one point to test. And I pick this, you don't have to pick 0, 0, you can pick any point you like. I pick it because it's easy. And when I tested it, I got false. 0 not bigger than 6. Not a solution. So I know the solutions are either this side or this side. It's all or nothing. Since this one didn't work, they're all not going to work. That means the solutions had to be here. Think about it, think about it, think about it. Yeah.
When you were doing the 3, 0, you said 12 plus 0.
Oh, 12 plus 0. You're right. 12 plus 0. And 12 is still bigger than 6. True. Still true. You're right. Thank you. You caught me. Other questions? No? Great.